Hello, ladies and gentlemen, and welcome back. We're looking at question 15 now. And what does it say? Equality, or I guess this equal sign here, for the limit as h approaches 0 of sine pi by 2 plus h minus 1 over h equals f prime at a. So it's the derivative of some function at some value holds for, and then they're giving me possibilities. Is the function sine of x and a is 0? Sine of x pi by 2, sine of pi by 2 plus x. So there are lots of possibilities. There's two ways I could see to go about doing this question. One way is that you recognize the limit they've given you as a first principles derivative and try and match up the function like that. The other way to do this question, I would say, is probably compute that limit as you naturally would. Okay, you'll have to use the sign of a plus b sort of formulas in order to cancel some things out. But calculate the limit on the left, and then for each one of a, b, c, d, those are different possibilities, use that f and that a to get f prime at a, whichever one matches the answer of the limit that you got, the limit on the left-hand side, that will be the one you circle. Okay, so if the limit on the left turned out to be 3, it's not 3. But if it turned out to be 3, and then we found out, oh, c, sine of pi by 2 plus x. When I take that derivative and I plug in a as pi by 2, I get an answer of 3. That means that c is the answer. Okay, but that's sort of a roundabout way to do it. It's a harder way to do it because we tend not to emphasize the sign of a plus b style formulas. Yes, you should know them. Yes, we did talk about them in class. Yes, we did them when we used we did use them when we did first principles derivatives, but it's not always the most obvious thing that comes to everyone's mind. It's sine of a cos b plus sine of b cos a, by the way. So what I'm going to do is I'm going to say, well, this derivative is what we're talking about, and all the possibilities look a lot like this sign up here. So is there a way to say, well, this over here looks exactly like a first principles derivative? Absolutely, we can do that. So we've got the limit. So h approaches 0. Sine of, what is it? Pi by 2 plus h, I think. Yeah, pi by 2 plus h. Minus 1 over h. Now, if this were to look like a first principles derivative, it would look like something like h goes to 0, f of a plus h minus f at a all over h. So let's ignore this fellow for a moment and compare. What have we got? Well, I've got my h's on the bottom. Great. I've got something plus h and something plus h. And I've got a nice fixed constant, f at a. So matching things up, and I guess we could even talk about this f here and this function of something plus h here, we might begin to guess maybe f of x is sine of x. Maybe a is pi by 2. Now that's certainly one of the possibilities, but let's double check. For example, is f at a, is sine of pi by 2 1? Because if it's not, maybe we're a little wrong. Okay? And that's possible. But sine of pi by 2 is indeed the one that our setup predicts. We should expect f at a, sine of pi by 2, to be 1, and it is. So by comparing and remembering how our first principles derivatives are set up, we can very quickly answer this question. Don't actually have to compute a limit at all. Sine of x and pi by 2, which is b. So that's going to be our answer there. All right, up next will be question number 16. I will see you guys for that in the next video.